Okay, in this presentation what I'm going to do is look at indefinite integrals. Okay, so this is just a quick tutorial sheet question. It's sort of an introduction to to integration. So what I have here is question A, is I started it there just to sort of get us going. So we have 5 times t to the 8 minus 4 times t to the 5 plus 3 times t plus 2. So this is an integral with respect to t or dt. Okay, so what we're going to use here is the power rule. Okay, so we'll just actually sort of start us off here. T to the power of n in this case is t to the power of 8. Okay, and the integral of that is t to the power of n plus 1. So in this case that's 9, which is 8 plus 1 over n plus 1, which is again 9. So just disregard the 5 for a second. The integral is of t to the power of 8 is t to the power of 9 over 9. Okay, so when we have coefficients like 5, we just sort of just put them in at the end as an afterthought. So I'm going to do something similar here. So 4 times t to the 6 over 6. Now I'm going to leave this alone, but you can actually simplify that as 2/3. Okay, plus 3t squared over 2. So in this case, t is actually t to the power of 1. Okay, and here we have 2, but we're going to sort of consider that as 2 times t to the power of 0. So in this case, the power is 0, and the power of so n is equal to 0, and n plus 1 is equal to t. So essentially, we're left with 2t. Okay. Now, essentially, just in the case when you have a constant, just multiply it by what's ever here. Okay. Last but not least, the coefficient of integration plus c. Okay. So that actually is good enough to start off with. Okay. You can try simplify them on an ongoing basis, but I'm not going to sort of do that this time around. Okay. So the integral of 1 over x plus 1 over x squared plus 1 over x cubed. I'm going to rewrite that as follows. That is x to the power of minus 1 plus x to the power of minus 2 plus x to the power of minus 3 dx. Okay. Now, this is a special case. The integral of 1 over x, or x to the power of minus 1, we can't use the power rule here. So if you actually check your integration tables, this is actually, the integral of that is actually log of x, or correctly, log of the absolute value of x. Okay, that's just a special case that you would look at from your tables. Okay, so just watch out for these sort of special cases. Now, everything else is okay. So this is actually 1 x. Now we can use the power rules here. So we have n is equal to minus 2, n plus 1 is equal to, so we have minus 1. So we have x to the power of minus 1 over minus 1, okay, plus x to the power of minus 2 over minus 2, okay, plus c. We can actually re-express that as follows. Oops, that should be a minus there. Just watch out for that. Remember the minus 1 here it turns this in sort of makes that minus. Okay, x to the power of minus 1 is 1 over x, and so on. We do something very similar here. We have a minus 2, so just be careful of the signs here. We have 1 with the 2 stays underneath stays part of the denominator, so stays underneath the line. There we go. And we can re-express x to the power of minus 2 as 1 over x squared. So it joins the 2 below the line. Okay. And yeah, that's grand. I don't just check my solutions just to make sure I don't mess it up. Now, the next one looks awkward. Okay. So e to the x. Okay, so we have 3 times e to the x. Now this actually works out to be something very simple. The integral of e to the x is just itself. Okay, the 3 we don't have to worry about. Okay, we just treat it as a constant, so we actually end up with 3 times e to the x. It's actually, that's that part of the answer. And then the plus 1 is actually plus x. Okay, and again, the integral, the coefficient of integration plus c. Okay, so move on to the next ones. There we go. So 5 times cos of x. Okay, so essentially what you have to do here is just go to your tables. Okay, and the integral of cos of x is simply sine of x. So 5 times sine of x, okay, minus 7 times, I have a little bracket there. I was just, don't really need, I'll just put that in the brackets there just to actually just sort of keep it. Oh, I do need to, sorry. It's close this one off here. Never mind. Silly me. So the integral of sine of x is actually minus cos of x. Okay. And plus c. Okay. So we have minus 7 times minus cos of x. So the minuses cancel out. So we're left with sine of x plus 7 cos of x plus c. Okay. And yeah, that's grand. Now, this one looks complicated, but it's actually fairly straightforward. Essentially what we're going to do here, I'll just write it here to one side, is re-express that as square root of x is x to the power of 1/2 plus x times x to the power of 1 times x to the power of 1/2 dx. We can rewrite that as x to the power of 1/2 plus this part here, just add the powers, x to the power of 3/2 dx. Okay, now we can use the power rule. Okay, so in this case, n is equal to 1/2, n plus 1 is equal to 3/2. So that's, sorry, that's x to the power of 3/2. Little bit awkward looking there. I should have tucked it up a little bit more. Over 3/2 plus x to the power, in this case here we have 3/2 as n. N plus 1 of that is 5/2. Okay, over 5/2 plus c. Okay, and we can do a little bit more with that, and essentially we can actually just rewrite that as 2/3 of x. Essentially just multiply above and below here by 2/3. The 2/3 will cancel out with 3/2, so we have 3/2 plus 2/5 x to the power of 5/2 plus c. You can actually try and simplify it a little bit more, but I'm actually happy enough with that now. Okay?